Okay, hello everyone that has joined us. Welcome to this walkthrough about post-processing and automation of 3D printed parts with AM-Flow PLM Group and DyeMansion. Hope everyone can see the agenda. I'm getting some weird feedback here. Let me just make sure. I'm seeing that screen sharing is now paused. I'm sorry for that. Let's see if it works. I'm sorry, guys. Right, here we go. This seems to do the trick. It's a bit like showing Windows 95 for the first time. Right, here we go. We're back on screen. So, as I mentioned before that brief interruption, we want to go back one slide because we want to have a quick look at the webinar agenda. We're at the introduction stage. We have some poll questions coming up along these 45 minutes. And we have our speakers, Carla Swicker, Commercial Director from AM-Flow, and Greg Gratzky, who is the Regional Sales Manager for DyeMansion, and myself, who is hosting this walkthrough here today. And I'm Matthias Christensen with PLM Group. Just a few quick notes about PLM Group for those of you who've never met us before. We are the biggest reseller in the Nordic and Baltic region for Dassault Systèmes and SolidWorks. Since 2014, we also work with 3D printing, where we offer a number of 3D printing solutions from brands such as Markforged, HP, DyeMansion, and 3D Systems. Our motto is, we make you innovate, and we enable this by creating 3D ecosystems comprising both software, know-how, consultancy, support, and of course, 3D printing. And we have a number of offices throughout this region where we operate. And we serve some 6,000 customers, both on the software and the 3D printing side. But enough about PLM Group. Let's dig into today's walkthrough. And we're actually going to start with a poll question. And you will see a screen now where you can vote. I still see some people answering here. So we're going to give it just a bit more time. Okay, and poll is complete. So the question, what do you believe is the biggest contributor to the cost per part? And multiple answers possible. And of course, a majority answered 60% manual labor, 20% data preparation, 20% 3D printing, and 60% post-processing. So that's the first of the polls. Sorry about that. We need to move to this screen. So with those answers in place, it's now time for Carla Swicker from AM-Flow to give you the lowdown on mass 3D printing and the bottlenecks that arises when you scale 3D printing for volume production. So Carlos, feel free to go ahead. I will assist you with changing the slides. You just let me know.
Please go ahead. Thank you very much, Matthias, and welcome to everybody online present at this webinar. AM-Flow, just as a brief introduction, we specialize in workflow automation, which is basically about taking away one of those major cost contributors to the cost per part, a 3D printed part, which is manual labor. We aim to make it a cheaper process. Ultimately, we want to support the growth of additive manufacturing in general. So if we just go through the next slide, let me just talk you through what our vision is, basically. For the past couple of decades, we've been investing heavily in all sorts of workstations. You know, we found out that we could print, great. Can we print better? Yes, improve it. You know, we've got innovation in the printing, we've got innovation in materials, we've got the software component, and then also adding post-processing to even enhance the added value to a particular printed object. Now, this is what we've been doing for the past 30, 40 years. But if we want to put a stake in the ground, then effectively what we want to be able to be doing is actually build AM factories. And that is actually, therefore, the reason why we say we want to challenge that 80 trillion marketing of manufacturing industry, okay? But we need to cooperate with a number of players at the same time. So let me take it further on. So what is the key contributor is the poll question of the cost per part. Now, on the left-hand side, you'll see actual data represented in that slide. My background is, amongst others, at Shapeways, and we produce a lot of stuff. And the first year, we invested heavily in the machines. Material was still expensive, and we only had a relative minor part of labor costs. Once we were growing and producing more, we added a couple of new printers to it. We negotiated down the cost per material, and we still had the labor cost. Gross margin in the production site was going up. Great result. Until year 10, when suddenly we saw that the gross margin of production was going down. The costs were increasing. And when we did our analysis, we found out that the key contributor to this process is actual manual labor. We could get our machines running almost 24/7. We could renegotiate all the material costs, but we could not renegotiate all the labor costs. Actually, adding a printer up front meant that we had to recruit 2 or 3 people at the back end. What were they doing? They were identifying and sorting parts. Now, if you look on the right side of this slide, of the 2 pictures on the left, most likely you could almost count how many parts are there. I'm going to give it away to you. It's 13. Now, the human eye can see it, count it, and can place it. But if we are going to increase volumes, and that's what is happening right now, you get the situation which is the picture on the right. Now, you have to order all those parts to be able to even create that very neat distribution of all those parts, let alone be able to identify the actual part itself. And that is a challenge that we've been having to face in the past sort of 5 to 8 years, with the increasing volume coming out of printers. By the way, printer manufacturers wanting to build printers that produce 10x more. So we're all going to go down a volume path, which is only going to increase. So this is the issue that we dealt with and we addressed. So, and that's why we're talking about cost per part. Too much time, people handling all these parts, breakages, loss. We have to stop it. We need to automate. Next slide, please. So, what 3D printing is basically a digital concept. We've got the design. It is completely digital. Now, manufacturing through printers is completely digital. And yes, that picture of a box with all these parts, this is a real life photograph of one of our customers dealing with literally on paper which part and trying to identify it. It doesn't work. This is the analog issue that we're trying to address. That is the current bottleneck at the moment, and we have been able to automate this. Next slide, please. So we have got this suite of solutions that will enable it. I'm not going to address our product portfolio at the moment, not really, because I think it's much more important that our listeners here in the webinar understand that what we're addressing is one of the key KPIs of additive manufacturing, which is cost per part. And of course, to grow the market, apart from cost, it's lead times and finally also quality. And that's where also companies like DyeMansion come in, where they are continuously improving the output of 3D production. But we have this full suite of solutions that will help you build up what we want to call an automated end-to-end digital production line. Next slide, please. This is one of our renders for a client of ours in which we've actually designed the place where our solution can be placed within the overall layout of their own manufacturing location. So it is not just about placing this somewhere, it's about understanding where it makes sense. And 9 out of 10 times, this is something that will be close to the DC, so to the shipping department, you know, the final step in getting your prints out and getting them to your customers. So this is a render made for our clients, but the next slide is actually the baseline on which we base all these drawings. So on the bottom right, you'll see order planning. That's where the design comes in from a client, then it goes to the left-hand side, the printing units, wherever, how many, whatever technology may be, etc., etc. So the first order planning is all about pre-processing, then it goes into printing, and once it comes out, you all know the process, especially in SLS and MJF printing environments, cooling it, and then once they've been cooled, cleaning and blasting, and then any kind of post-process enhancement step, which is polishing, smoothing, dyeing, vapor fusing, chemical surface treatments, you name it. The arrows that we've drawn in here is actually the way each part flows through this system. And I want to emphasize each part. This system is built around the principle of one-piece flow. So we are able to track and trace a single order, no, a single part in an order. So it's not about ordering and then following whatever's in the order. No, you can now, because each part in an order might have a different bill of materials, a different set of post-processing steps, we are able to follow each individual part. And those light yellow lines on the presentation slide just show you the movements that are all possible. And ultimately, you can go multiple times through identification, switch it from one-piece flow to batch processes that take place, for instance, when you're dyeing or polishing, and then re-recognizing parts afterwards. This is the basis of what we present to our customers to let them understand this is your workflow. And you may have to revisit it, but we can automate it. Next slide, please. And we've been very fortunate. In 2020, we were the winners of Startup Challenge in Formnext, which was a fully digital environment. And this year, we got the Innovation Award from the Customer Choice, so the listeners of a webinar, a full day around additive manufacturing, and we received the Innovation Prize. This was extremely important for us. We listen to the customer. It's the market that's calling us and saying, we need this. We've got a pain in the market. And we've added here a quote of one of our very early customers, which is basically, it's a reduction in throughput time, leads to cost savings, reduce identification time, reduce failure costs, etc., etc. And that's exactly the aim that we have, ultimately bring down costs. Thank you very much for that one. And I think the next slide is about how we connect. So we connect all our data with your existing software environment, your MES or ERP system. We have a full API connector for that, and we pull out specific data points, or actually you push those data about the batch, the STL file of a particular design, and the process steps necessary to deal with that particular part. So that is a fully digital environment. Next slide. Right. Do you have a, exactly, sorry, Matthias, go ahead, take it away.
Yeah, no worries. No worries, Carlos. Let me just bring up the next poll question here. So the question is, do you have a, within parentheses, colored high volume / high mix production? And let's make sure you all can vote. It's a simple yes or no, and let's see, collecting responses. Still in progress. Someone is either away from keyboard or too shy to answer. I think we can. I think we can pause. Oh, wait, that was another one. Let's see. There. So yes and no answer. 43% said yes, and 57% answered no. Let's see if I can share that result. Bear with me here. Yeah, it's all visible. And then I'll go back. So let's move on. We have some ground to cover here. We're going into the next section of this walkthrough. And it's time for Greg Gratzky first and foremost, but then Carlos Vicker will join this walkthrough of examples of automation solutions for the post-processing of 3D printed parts. Greg, welcome, and yeah, take it away. I will control the slide deck. You just let me know.
All right, thank you very much, Matthias, for this very nice introduction, and thank you very much, Carlos, for introducing us to the challenges of the post-processing. Yeah, so I'm representing DyeMansion company for since 2015. We are responsible for turning your raw parts into high-value products in an automatic, scalable, and repeatable way, which is one of, which are very important factors for manufacturing, and what in terms we are talking about 3D printing here. So one of the most important thing that you actually mentioned, Carlos, is that when we are actually scaling our production, it's not the cost of the material which is growing, it's not the cost of the machine which is growing, it's a cost of labor. And so it shows us really that labor is not scalable. Yeah, so more machines we add, the more manual job we actually have to deal with. Yes, and it's an absolute important factor that we should really pay a lot of attention to the automatic and scalable post-processing. Yeah, so what DyeMansion is doing, we are responsible for fulfilling 3 stages into creating a final part made of with the 3D printing technology. So as you are delivering us the parts and you're responsible for the distribution of these parts, we are particular stations that helps to either dismiss the disadvantages of 3D printing and add the value that is a difference. So this value lays in a difference between the parts that we see in our everyday life and the part that we see that is coming out from the printer. And one of the most important thing, well, maybe from the other side, is that not all parts that are coming from the 3D printer requires coloring. Not all parts require smoothing. Yes, but all parts require certain cleaning. And that's the first station where we are coming actually. So it's a post-processing called cleaning. Yes, we as a DyeMansion, we grow and we develop our products thinking in mind this scalability. So when this batch of parts is coming to us, and it's not described by any geometry, it's basically a bag of white powder where some parts or several hundreds or even thousands of parts are in, and they require to be cleaned. Yeah, obviously in the manual blasting there is no automation, it's not scalable at all, and therefore we came into play with a solution that enables you to automatically clean your parts. Yeah, but so in the form of PowerShot C, as we all know here, it's not scalable. Well, it is scalable, but it doesn't give us any industrial feedback. Yes, so the machine does not does not state when when there is a slowdown. It does not say how many parts it can handle, and it's very difficult to think of particular geometries if we are talking about one single blaster. That's why we came up with a solution which is called the Performance Series, that can be fully connected to a cloud, gives us constant feedback about the current statuses, and is more plannable. So we can think of the possibilities. We can think about the different geometries. And if we go to the next slide, this machine has a much wider cleaning platform based on the conveyor belt, where we can in one run we can make over around 500 pieces of eyewear or 30 shoe soles. Yes, which let's say gives us certain production volume right now at this moment. Yes, and the whole process of cleaning takes around 15 minutes. Without putting out the parts from the machine, we can basically start mechanical smoothing process. So the machine first of all shoots the parts with the glass beads, with the plastic media, with the plastic media, sorry, small plastic medias, and then after cleaning the remaining powder residue, it's automatically switched to a wider, bigger plastic media and helps us to smooth the parts automatically. Yeah, then we can go to the next slide, so we got two ways of smoothing of parts, automatic smoothing parts. One is mechanical, where we basically hit the parts with hundreds of thousands of small plastic balls. And this gives us the surface quality quite similar to what we have with the electronic housings, for example, where parts are scratch resistant. They are slightly glossy, but not as glossy as injection molding. For that, we have our next machine. If you press Sprays Mat, we got vapor polishing system, and this machine is also fully automatic. So it allows us to give us very, very important feedback about the current statuses, about the current process. So it allows us to connect, let's say, to get the notification on our mobile phones or on the computer, where we can get the information that this machine is currently running process with this number. Yeah, and important factor is that this process is fully customizable. So we can define particular baskets to a different finishing levels. And here we are not talking about badges anymore. We are talking here about the parts which will have a particular surface finish. So here we require certain distribution which can be delivered by AM flow to where one batch will be smoothed in a very strong mode, another batch will be smoothed in a very delicate way. Yeah. Yeah, so we can go to the next slide. So this is exactly what I'm talking about.
Exactly, yeah. So what you've seen here is basically that once we've identified a part, and it doesn't matter in which stage that part is, we can redistribute the part or reroute it into the next stage. So we can route it to whatever is necessary, the bill of material of each individual 3D printed part. And because you can do that, you can automate it, and literally you cannot see it here, but in the previous slide, what you saw there was the point in which a cobot is actually has the bin on top of it in which we sort parts, and that cobot can then run to the next department fully independently, internal transport, and at the department, basically you can then hand scan a QR code on the carrier. That's very important. The stuff, all the parts go into the next batch process, which might be blasting or whatever at various levels. And when you're ready with that, that same carrier with the parts treated come back to the end flow and then get redistributed into the next specific step in the overall post-processing flow for individual part, or ultimately they can be bagged and labeled and made ready for shipping. So let's go to the next slide, or is this, are you going to, let's actually try and go and show the video. And there you go. So here you see a bin with various parts. This is our picking robot that can pick up the parts and place them on the conveyor belt. And it doesn't matter which size, format, or form. Irrespective of the way parts are lying on that conveyor belt, they are photographed and identified. And you see those photographs and the identification on the operating console. The sorter then sorts all the individual parts into the appropriate bins. And the other option is, if something needs to go out to shipping immediately, like for instance, these pair of glasses, they get bagged and it has a label on it and everybody knows what needs to be done with that particular part. And in this part, you see here the aforementioned cobot that will pick up a bin and ride this specific bin into another docking station somewhere in another department, whatever that may be. And as you can see, it's riding around in our showroom in Eindhoven, where we filmed this video. And a full-blown version of this will be also presented during Formnext next month. So we'll have all these modules up and running and showcasing how that looks like in real life, rebuilding basically a end-to-end digital production line. One of those centerpieces of this is the AM Logic, which is our proprietary AI software. We have an API connector. What happens in the computer vision and therefore identification part is geometry-based object identification, which is a machine learning entity that actually gets better the more you use it. Because we can track and trace, basically, or we can identify any part, we can track and trace them wherever they are in the factory. So you do no longer lose parts. We will feed back all that data also to your ERP. So even if you get audited and they ask you, where is this particular part in your factory, you can immediately say, I know where it is. So this is an important way of actually collecting data around your production process. And ultimately, we also believe that this will also contribute to certifying your production process, because that is going to be another requirement in due course, that we actually certify and understand how a part is being made and what steps have been transitioned to make that particular part. Next slide. Over to you, Greg.
Yeah, so we are coming back to the vapor fuse surfacing. Yeah, so what we already went through is that we went from a bag of white powder, which is filled with the parts, and we were able to depowder it, and we were able to smooth it out mechanically. We were able to recognize the geometry and deliver these parts to a different surfacing levels. Yes, it's very important for us to let's say to pay a special attention to the power fuse because this machine was also, let's say, developed to meet the industrial standards. Yes, so we are not there in a, let's say, in factory or industry. We should have no more space for experiments or for dangerous substances. Yes, so this machine enables us to be placed for, well, it can be based in a shop floor. It is fully cloud, it is fully always connected to the cloud and gives us constant feedback. Yes, it also does not require any additional special site preparation. You don't need to have any special air conditioning or safety features. You can immediately run this machine inside of your factory. Yeah. So once we have our geometry recognized, once we have it distributed among different baskets where we have different smoothing levels, we can perform smoothing and then still divided them into different baskets. We can process them to the further processing stations, where is, for example, the coloring.
I'm sorry about the PowerPoint here. There's obviously some sort of glitch or bug. Let's see if we can work it out by. No.
That was it, almost.
Yeah.
There you go. That's it. And this is exactly what Greg was just describing. Our sorting solution on the right, you can see it. But on the left-hand side, this is the actual screen on the operator console. And it's a top view of the sorting exits of our AM sorter. And this is a dynamic, fully free configurable solution. You can actually just pick up with your finger, because it's a touch screen that you have on the operator console, and place whatever the next step is or the requirement into a particular bin. So if you want parts that need to be polished, or parts that need to be colored green, or parts that need to be colored blue, you can actually dynamically switch in any way and spread it across all the bins that you have available. So this is a top screen that basically enables you to effectively, as a quarterback, throw out wherever, in every direction of your manufacturing plant, where the parts need to be for the next step, all based on one-piece flow, and then collecting it for batch processes and then back into one-piece flow, because we don't know what the next step might be for each individual part. Next slide, please.
Yeah, indeed. And the next step can be, for example, coloring. So, you know, color plays a very, very important, or even not the most important factor in creating the final parts. Yeah. So what is important for a DM60 is that also it does not require almost any human power. So machine can be, you know, you just load the machine, scan the cartridge, that can be also distributed to a particular baskets which were assigned by Aimflow, and basically you start the machine as it is. Yeah, the machine has a fully traceable, well, it's the process is recorded. Yes, so if, for example, part will not behave as it should, you can come back to the machine, check the log, and you can see if there was, for example, a temperature drop during the process. So you can easily get rid of the future possible mistakes. Parts are finished after approximately 2.5 hours, and they are slightly wet, but they are ready to use. So you can easily dry them on a standard room condition, pack them and send them over directly to the customer, or sort them if there are all parts, for example, dyed in black, and you just need to distribute them among the different geometries, among the customers. Yeah, next slide, please. Then. Yeah, that's exactly what's all this how the process looks like. Basically, we are, as I said, we are filling the basket, we are scanning the cartridge. Cartridge has all important informations that you need to operate the DM60. You put the basket back to the machine and press start and leave it for 2.5 hours.
And wouldn't it be great, instead of having seen those hands and putting a bin, tipping it over into your system, that we provide you with a robot that actually slides it into your machine, Greg? That would be great.
Yeah. Well, I was like thinking about you know packaging these machines in a let's say automatic, nice robotic way. Yeah, and I think that we are developing this machine just thinking, having that in the, in the front of our heads.
Absolutely, great fun, good. Next slide then, there you go. And again, I think the important thing that we want to just reiterate at this point, again, it's about going from one-piece flow back to batch and then to one-piece flow again, et cetera, several times throughout the overall manufacturing process for each individual part. Now in the poll earlier on, do you have a high volume, high mix kind of environment? Of course, there are going to be a number of people who say, yeah, but I don't have that high mix. It's not going to be an issue for me, this kind of stuff. Well, potentially you're right, but I just want to throw in some ideas around that. If we're going to start increasing additive manufacturing production, a lot of people are thinking about serial production. Mass production tends to be serial. And if you look at basically the economics of a printer, just nesting one printer for a serial production gives you a lot of free space to place other parts. And again, it might be that your customer says, yes, but I don't want any other parts printed in there, which just makes that part potentially more expensive. You have virgin powder, you use it once, and then there's a lot of space in the nesting that you do not use, and then you're stuck with secondhand powder. In the typical high volume, high mix environments like service providers, you can have, they make literally it almost a Tetris game of fully optimized nesting, the optimal density to produce high quality end products. And that is a way forward if you're going to increase the volumes. I think it's going to be very expensive in doing serial production, just a series of a number or 100 of one single geometry. And if you have to increase that volume, add another printer, et cetera, I think that's not going to work. I think by default, we will be working towards high volume, high mix. So I just want to place that as a way of thinking at looking at the economics of your production line and making the best of what is actually one of the most expensive assets in your production line, which is the printer. So that's about one-piece flow and batch processes and the switching back and forward in that sense. Which brings us to the next slide, Matthias.
Yeah, absolutely. So the automatic post-processing also gives you additional values which are not visible at the very beginning. Yes, so when we are thinking about the production, we are thinking about one part that looks good, feels good, have fantastic geometries. Yeah, but if we are going deeper into that, we need to consider that our parts might require to pass some of the certifications. Yes, let's take an eyewear, for example. It's an application that it's very, let's say, suitable for 3D printing from the first perspective. Yes, we got a customizable eyewear manufacturing. Eyewear factory where you can define your geometry. You have a complete freedom of the design. Different colors puts you even more into this customization. But as a manufacturer, first of all, you need to consider that your product has to be fully biocompatible. Yeah, and if you are contract manufacturer, your customers might require certain quality management implemented into your factory. And if you have a human power and the risk of entering to human error, it's very difficult to achieve this quality certification. Yeah, so the automation of your post-processing basically helps you a lot in getting into more customers. And we are not talking here about one prototype. We are talking here about mass production, which is much more, let's say, it generates much higher revenues. Yeah. Next slide, please.
Yeah, so we just want to almost close this session by actually talking about the benefits. I mean, we're doing this, of course, for your business, but ultimately it's going to be also your customer. Now, if we just look at the economics, I sort of raised it already within the context of the high density, high volume, high mix kind of process. This enables you to scale your business, to increase revenues, because you can take on different kind of orders from different customers. The aim is cost price reduction, and of course, maximize the capitalization of the assets that you have already, which are your printing, your printers basically. But also by introducing this digital process, you get a better workflow efficiency, tracking and tracing, which potentially could lead also to certifiable production processes, automatic data entry, automatic counting. It's a repeatable process. And one of the latest things that we're talking about, of course, is in terms of safety and all things digital, is the industrial digital thread, that you can actually really follow how a product has been created from the very beginning to the usage, to breakage, and then feeding it back the information why it might have broken. Finally, lead time minimization, minimizing delivery mistakes, same-day delivery, audited processes, custom bagging and labeling. These are the things that might be important for your customers. And these will bring you also to the next level, that your customers will increase, at least considering a number of applications for 3D printing. And that's what this game, at least for us here in this webinar, it's all about. We want to grow the AM industry as a whole. You guys out there with your production facilities, and Greg with DyeMansion, Matthias with the PLM Group, and ourselves as supporting actors in enabling you to achieve those goals. Next slide, please.
Okay, the final poll question of the day. It's a simple binary answer here, so yes or no. And we are in progress. Let's give it a few more seconds. See if we can get everybody on board here. So far, more people are answering yes than no. Let's hope that sticks. For everyone's sake, I suppose. And a few more seconds. So poll question number 3 was, have you considered workflow automation in the post 3D printing process? And I think we can close this in just a few seconds now and have a look at the answers. So 80% saying yes, 20% no. Kind of a giveaway also for the people attending this walkthrough, of course. It would be strange not seeing these results. And with that final poll question, it's time to wrap up. Greg and Carlos, the poll questions and the results of these 3 poll questions, was there anything that surprised you? Anything you want to comment on?
So if I can actually add one sentence to the final poll, where where 80% of the participants said that yes, they are considering implementation of the automation their 3D printing post process. It's like it's a, let's say, natural step as when we are using our printers for manufacturing. Yes, it's very important if we are going for certain volumes. Yes, as we can pay a lot of attention to a single prototype, because there are printers which are made for this purpose. If we are going for powder bed printers, we are not talking here about one prototype. Yes, it's not always cost effective. Yes, we are talking about hundreds of thousands of parts where without automation, the appropriate impression and appropriate behavior of these parts will never take place, basically. There is a reason why people go for this powder bed printing, and the main reason is the volumes. It's the speed. Yes, and with the post-processing without automation is a bottleneck. Yeah, it dramatically increases the cost per part, and it dramatically increases the time that we need to spend on our production. Yeah, so I'm not surprised, and obviously we are never starting with implementing the complete automatic post-processing workflow. We are starting with the small steps. We are starting with the one printer, maybe a cleaning machine of so-called with our PowerShot C, for example. But having this PowerShot C, this automatic station, opens up the door for a future scaling up. You can really add a second printer, third printer, and then you go to a point like one of our best customers, 3D Print UK. They are manufacturing 6,000 parts per day. I can imagine what a nightmare it is, and they are fully customizable. Their job is to basically fill their build volume to the maximum, and then distribute these parts. And sorting these parts, processing them, it's a nightmare basically without automation.
Anything from you, Carlos? Final words?
Yeah, thank you very much for that. Yeah, encouraging, of course, to see these numbers coming through. The key thing around it is we're at the start of this automation shift. All right, this is something relatively new in the industry, and people are looking now for solutions. And thank God, a number of solutions are now ready for market and they're available. I think that's the first sort of observation I have at this very moment, which is great. The other thing I'd like to add at this point in time is that to the listeners is that even if you're not producing, something as wicked as 6,000 parts a day, which I think not everybody's producing at the moment, Greg, but I think there is an opportunity to get onto the automation ladder. And this is not a silver bullet. It is about try the first thing, and then the next thing, and then build out the operation so that it becomes a fully automated end-to-end digital production line in the end. So I'd like to invite the listeners of this webinar to actually put a stake in the ground. Where do you think you're going to be in 5 years' time, and how are you going to get there to make that happen?
Goody. Let's see if we can just say a few final words. Formnext is coming up, and of course, both you guys at Aimflow and DyeMansion will be present. So if you're going, please take the opportunity to either visit their booths by yourself or register for a guided tour, including free tickets with PLM Group, and we will tailor-make your tour of this year's Formnext coming up next month. With that being said, I would like to first and foremost thank the speakers here today, Carlos Vicker from Aimflow and Greg Gratzky from DyeMansion. Thank you so much for taking the time and making the effort. I appreciate it, and I'm sure the audience does as well. And thank you for joining this walkthrough on automation in post-processing of 3D printed parts. Thank you.
Thank you very much.
Thank you very much.